Hello class, good evening. Welcome again to my channel, Applied Science College. Today we are just going to discuss, I'm just going to ask you some questions in physics subject, and then we shall be able to answer them when we shall meet next time. So I just want to ask you some few questions here. Especially, these are questions for the Form 4s, and you go and try them on your own to see if you can be able to answer them perfectly. Then after some time, we shall be able to discuss the same paper to see how these questions are supposed to be answered. So, without wasting time, I'm going to ask you, I'm just going to ask you all these questions in as far as section 1 and section 2 are concerned, and then we shall be able to see how these questions are supposed to be answered. Let me start. 1. The figure below shows part of the scale of vernier caliper who are completely closed. Whose are completely closed. State the zero error. The figure below shows part of the scale of a vernier caliper whose are completely closed. State there is the zero error. As you can see there is a scale in the vernier caliper. So let me just go to question 2. Explain why the body going round a circular track of a constant speed is said to be accelerating. 1 mark. Question 1 was 2 marks. Question 2. Explain why a body going round a circular track at a constant speed is said to be accelerating. 1 mark. Question 3. The figure below shows the glass capillary tube dipped in a liquid at a room temperature. As you can see, the drawings there. So, 3A, indicate the diagram the level of the liquid in the capillary tube when the liquid is heated slightly. 1 mark. Then explain your answer in part 1 above. Another 1 mark. Then question 4, it states that a balloon is filled with the helium which is higher than air. It is observed to rise in air up to a height of 40 meters. State the reason why the balloon stops rising. That is 1 mark. Question 5. The figure below shows the temperature changes against quantity of heat supplied to 1 kilogram each of liquids A and B. As you can see, on the y-axis we have the temperature, and then also on the x-axis we have the quantity of heat. So we have there 2 liquids A and B. So the question is, which of the 2 liquids has a higher speed? It reads, let me repeat. Which of the 2 liquids has a high specific heat capacity? Give a reason. 2 marks. Then number 6, a box on an inclined plane is under 2 forces as shown below. F1 and this force 1, and then on the other side it is 10 newtons. So as you can see, the toy moves upwards with a constant velocity. State the F1 and give a reason for your answer. 2 marks. Question 7. A water tank with a height of 3.6 meters is full of water. A thin metal plate rests flat at the bottom of the tank. If the plate has an area of 2 centimeters cubic. Determine the force exerted on the thin metal plate if the density of water is 1,000 kilograms per cubic meter and the atmospheric pressure is 104,000 pascals. 3 marks. Number 8. The figure below shows a uniform ruler balanced at the center due to action of some forces as shown below. A is a magnet of a weight of 30 newtons and B is a permanent magnet fixed onto the bench. As you can see that diagram, that is how it is. We have A, B, and then 10 meters, and then you have 50 centimeters, and then on the other side it is at 75 centimeter mark. So then on the other side we have the load of 8 kilogram, and then A, it is not labeled. Then the question asks, the question is asking to determine the force between A and B. And then question 9, it states, the figure below shows 2 identical flasks A and B filled with water. Show the level of water. Show the level. I beg your pardon. Show the level of water 1 minute after the bulb placed in between the flasks is switched on. Explain your observation. So as you can see on the diagram there, we have the 2 identical flasks, and then we have blackened surface and then the shiny surface, and then in between we have the bulb. So we shall be able to explain when we shall be discussing those questions. And then question 10, the figure below shows an loaded spring when supporting a load of 300 grams and wooden block. So the figure is there. As you can see, we have there the figure, a height of 12 centimeters, and then the load is 30 kg, 300 grams, and then the height is 8 centimeters, and then we have the wooden block there. It is, then the height is 10 centimeters. So calculate the mass of the wooden block. We shall do that. Then we have question 11. The figure below shows an uncompressible fluid flowing through a pipe. A1 and A2 are the cross-sectional areas of the pipes in the larger section and smaller section of the pipe respectively, while V1 and V2 are speeds of the fluids at the 2 sections of the pipe. As you can see the diagram there, I think it is self-explanatory. And then you have been told to derive the expression of the ratio of the speeds V1, V2 over V1 in terms of A1 and A2, 2 marks. Then we also have question 12. Apart from the base area, state any other factor that affects stability. Apart from the base area, state any other factor that affects stability. Then we go to section B. The first one was section A, now we are going to section B. So now in section B, it carries 50 marks. So we are just going to ask all of you all the questions that are on the section B, but when you'll be doing them, the instruction says always sometimes either to select any of the 2 questions out of the 3, and then you leave 1. But sometimes when we shall be revising, we shall just be able to deal with all the questions so that we can see how they can be able to be answered. Question 13. The figure below shows a setup of an experiment to determine the specific heat capacity of water. So that is the diagram. As you can see it, the way it has been connected, it has a thermometer, a voltmeter, and the ammeter switch, and then we also have the We also have the rheostat, and then we also have we also have some connecting wires there. So the data below was obtained from an experiment. We have the voltage across the heater, 12 volts, the circuit 1, current 1 in the circuit is equals to 1.4 amperes. And then we have the time T heating in 600 seconds, and then mass of water is equals to 0.4 kilograms. Change in temperature is equals to 6 degrees Celsius. Define specific heat capacity, that is 1 Mach. And then you have been told state the improvement that will be made on the setup to obtain the accurate results. State the improvements that will be made on the setup to obtain the accurate results. And then we also have use the above results to determine the specific heat capacity of water. 3 marks. The second question was 2 marks, and these ones are 3 marks. Use the above results to determine the specific heat capacity of water. 3 marks. Then you have been told also section B on the part B of that question, explain why the cooling unit in brackets freezer inside a refrigerator is placed near the top but elastic immersion heater in water tank should be near the bottom. 2 marks. And then you have been told also state 2 factors that will lead to increase in the rate of evaporation of a liquid. 2 marks. And then we also have question 14. A bullet of mass 24 grams traveling in an horizontal path with a velocity of 450 meters per second strikes a wooden block of mass 976 grams resting on a rough horizontal surface. After impact, the bullet and the block move together for a distance of 9 meters before coming rest. So Roman 1 of question 14a. Name the type of collision which takes place above. 1 mark. Name the type of collision which takes place above. That is 1 mark. 2. Determine the velocity of 2 bodies when they start sliding. 2 marks. Determine the force which brings the 2 bodies to rest. 3 marks. And then we also have B. So 14B, that is 14B. A missile is fired horizontally from the top of a cliff 320 meters high at a target of 56 meters away. If the missile hits the target, determine the horizontal velocity of the missile. The options are 3 marks. Then 14C, a graph below shows how a velocity varies with the time for a body thrown vertically upwards. You can be able to see that graph. Then we have been told, determine the distance moved by the body. 3 marks. Then 15, I think that is the last question. That is the second last question. Define the term efficiency as used in machine. Define the term efficiency as used in machine. Then we also have part B of that 15, question 15. Hydraulic lift is used to raise a load of 100 grams through the height of 20 meters. The radius of the effort piston is 1.6 centimeters. while the load piston has a radius of 8.0 centimeters. If the machine is 75% efficiency, calculate the velocity ratio. Calculate its velocity ratio 2 max, then mechanical advantage 2 max. Then Roman 5, energy wasted in using the machine 2 max. And then we also have a block and tackle pulley system is used to lift mass of 200 grams if the machine has a velocity ratio of 5 and efficiency of 80. And then sketch in the space provided below the possible arrangement of system if provided with the 2 block and tackle pulleys, each with the 2 pulleys, 2 max. And then last but not least, question 16a. The diagram in figure below shows an experiment to investigate the relationship between volume and temperature of a fixed mass of a gas at a constant temperature. So that is the diagram. We have the thermometer, water bath, and then we also have the stirrer, and then also the concentrated sulfuric acid, it's also inclusive, and then the dry air. Then heat is also applied at the bottom, as you can see in that diagram. So the question is asking on Roman 2, which measurements are taken in the above experiment 2 max? Which measurements are taken in the above experiment 2 max? So we have been also told to state the law being investigated in the above experiment 1 mark. Then 3, describe how the temperature above is used to verify the law 4 marks. Then you have been told also to state the assumption made in the experiment 1 mark. Then state the condition necessary for the body to float, another 1 mark. The current solid of volume 50 cubic centimeters displaces 10 cubic centimeters of kerosene, in brackets density 800 grams GH per cubic meter. When floating, determine the density of the solid 3 marks. And then we also have the last and the very last question. The other one was second last. So we also have another last question here, question 17, whereby it reads, the graph below was obtained when an experiment to investigate the variation of centripetal force F with the radius R of the circle in which a body rotates was performed. As you can see that graph, let me just put it close so that you can be able to interpret that graph very well. So you can see it. So they are asking a few questions here. From the graph, determine the angular velocity W of a body when that M is equals to 100 grams and F is equals to mw squared R plus C, where C is a constant. That is 4 marks. A stone of mass of 0.2 kilograms tied at a string in a wheeled in horizontal circle of a radius 1.0 meters of a constant speed of 3.0 meters per second. Determine the angular velocity of the stone, 2 marks. Then 2, the tension of the string, 2 marks. And then the number of revolutions the stone makes in 1 minute, 2 marks. So I hope that one has come to the end of the questions today in as far as physics is concerned. So when we shall be meeting next time, we shall be able now to go through those questions and we shall discuss them in details and we shall be able to know their answers. Otherwise, remember to subscribe my channel, to share, to give some remarks or comments just down the video. I'll be able to appreciate so much. Otherwise, continue following me and continue revising, especially for the chemistry practical. I started on titration practical 1. Now I've gone to an extent of titration practical 12. So if you are keen enough, and then you make a follow-up on those practicals, you will be able to gain your experience, and you'll be able to know how titration practical questions are supposed to be answered. Otherwise, continue following me, and we shall be able to learn more in as far as this channel is concerned. Otherwise, bye-bye, and we shall meet again. Thank you.